Hey guys, so today I have this H310 in front of me here, and this was sent to me by a gentleman named Peter, and Peter is one of my customers. He had bought a H310 mini with IT mode firmware from me, and later we communicated over email, and he let me know that he had actually tried to flash this H310 himself and ended up bricking the card. And so he offered to send this bricked unit to me to see if I could maybe experiment with it a little bit and see if I might be able to find a way to recover this. So anyway, I'm not sure if I will be able to or not, but I want to bring you guys along on the adventure here to see what might happen. So let's go ahead and put this in the R710, or the R720 rather, and see first of all what condition it might be in. Okay, that's installed. All right, let's power it up and see what happens. Okay, we have configuring memory. Alright, well, yep, this is definitely bricked. So we see here the error message, invalid PCIe card found in the internal storage slot, system halted. So the system won't boot with the card in it. Alright, let's power this off and take it out. Right. Okay, so I'm gonna take this over to my laptop and see what we can do with it over there. Obviously this unit won't boot, won't allow the machine to boot, so we're gonna have to do something else to get it to a state where we can boot it, and then maybe then we can flash some firmware or do something else with it. Alright, so here we are at the laptop, and this is the H310 that's bricked, and we're going to try to access the EEPROM that contains the SBR. So earlier I removed the sticker here, and basically there's two chips here that look like EEPROM chips. They're 8 pins, this one and this one right here, but the one with the sticker underneath it I believe is the one that's going to have the SBR in it. And earlier I took the sticker off and I took a close-up photo to figure out what's written on that chip, and it says 24C64, so pretty sure that's the EEPROM for the SBR. So anyway, I'll put a photo of that up on the video so you'll see that, because with this camera you're just not going to see what's on that chip. It's so small. So anyway, what I have here with me is a EEPROM programmer. And this is based on the CH341 chipset. And you can buy a kit like this off of eBay or Amazon for about $15. And it comes with all sorts of attachments and accessories. For me, I'm using this 8-pin clamp, so I'm going to clamp onto that EEPROM chip, and I've got it plugged into the 24-pin or the 24C I2C portion. The other side is usually for flashing like BIOS chips and stuff like that. So anyway, that's how I have this set up, and now I just have to clamp this onto the EEPROM chip. So you got to make sure that pin 1 is on pin 1. So the red wire here is pin 1, that's this corner. And if you look on the chip, there's usually a dot indicating where pin 1 is. So on the sticker here, there's a tiny black dot. So this is probably pin 1, but if the sticker was missing, you can look on the PCB and there'll be a white dot near where pin 1 is anyway. So pretty sure that bottom left corner is the one that's pin 1. And so we'll just make sure that we're clamping it on the right way. Okay. And once it's clamped on, looks like this amber light turns on. So, alright, so I think we're good to go here. Alright, so I'm going to go ahead and I'm going to switch over to the screen recorder. That way you can kind of see what I see on the screen a little bit better than through this camera here. Okay, so the program I'm going to be using to read the EEPROM is this thing called CH341EPROM. Alright, this is a project on GitHub you can find, and I'll leave this link in the description of the video so you can find this if you need it. But basically, this is a program that works with this CH341 chip that's on the adapter that I'm using for communicating over I2C to the EEPROM chip. Alright, so first let's just make sure we see the adapter here. So yeah, here it is, the CH341. Alright, and I already have the so you'll see that I already downloaded the CH341 EEPROM code, and I compiled it, and this is the program that we're going to use, and I put that in my path already, so you can see that it is in my bin directory. Okay, and I'm just using this folder. So I've got a couple of files here that I put on this machine before doing all this because I figure they might be useful. So one file here is a copy of the EEPROM contents from H310 Mini that's unmodified, and the second one here is from an H310 Mini that has the IT firmware that I put on it. So we'll have kind of both of these just to see, what we might find useful, and also to compare what's on it right now. And that's the thing that I don't know yet. So I want to read out the EEPROM contents and just see if if it matches any of these guys or if it's all zeros. As you might recall in my previous video, the problem with the the common procedure for flashing IT mode firmware is to first erase the SBR or write over it with zeros, and then to erase the firmware and then reboot. And if you recall, that ends up with a bricked card, because once you've erased the SBR completely, it will not allow you to boot up again, just like we saw earlier with this card. So anyway, alright, so here are the options for this program, and we're going to use I always like verbose, and the chip is 24C64, and we're going to read, and I'll call this H310 bricked.bin. Okay, so hopefully if everything's plugged in correctly and I've got that chip clamped on correctly, we should be able to read the contents of that EEPROM chip right now. Alright, so it looks like it successfully read it out, but let's take a look at the contents here. Alright, so it is 8K, so that that chip, by the way, is 8 kilobytes. And so obviously SBRs are usually like 256 bytes, so a lot of this should be filled with zeros. Let's take a look at the contents of this. So we'll look at it with hexadecimal offsets, and let's see, or hopefully, let's see. Okay, so the left column here is just the offset. It just tells you where you are. Okay, so we start at 0 and then it kind of goes up by 16 bytes at a time. Okay, and so this is where this content starts. And immediately the thing I'm noticing here is that I've looked at a lot of SBRs, so this looks a little strange to me, but there are, 10 bytes of zeros here, and yet we have non-zero content here. And this here looks like the PCI class. So 0104 is the RAID SAS controller class, PCI class. So this looks like it still has some remnants of the original SBR for the H310 mini before it gets flashed. So I'm not really sure why this is all zeros. This is not. And then 1028, that is the hex code for subsystem Dell. 1F51, I believe that's the mini monolithic. And then, and here we have the LSI vendor ID, and so that's 1000. And then 0073, that's the product ID for the H310 with the integrated RAID IR firmware, basically, or the original Dell firmware. So yeah, something definitely looks a little wrong with this SBR here. So let's compare this actually. So this looks like the SBR wasn't fully erased, and it looks like it's still retaining some of the content of the original Dell SBR. So let's look at what that's supposed to look like over here. So I have the original EEPROM content from a unmodified H310 mini in this file. So let's take a look at that. Okay, so yeah, so definitely there's something not right about this SBR that's on Peter's card. Over here you can see that the original SBR starts out with F661, 0022, 2000B34F, 00F8. So this is what normally looks like. And on Peter's bricked H310, that portion is all zeroed out for some reason. So this is kind of strange. I'm not really sure how this card got into this state, because normally during the cross-flashing process that you find online, the first thing is to write 256 bytes of zeros. So I was expecting all of these to be zeros, and it's not. So I wonder if in the middle of writing zeros, so after the first 10 bytes, something might have happened and it interrupted the process, and it just kind of stopped there instead of continuing on. I don't know, but in either case, this obviously is no good, and this is probably what's causing the card to not allow the system to boot, and as you saw earlier, throw the invalid PCIe card. So what do we do here? Ultimately, I think Peter wants me to put IT firmware on this card. So I'm kind of thinking that instead of putting the original H310 SBR back onto the card, that I would just try putting the IT mode SBR. So the IT mode SBR, by the way, here's what that looks like. Okay, so this is the IT mode SBR, and it looks a little bit different. Most importantly is that the product ID is 0072, and that's for the IT mode SAS controller. When it's 0073, that's basically a RAID controller. We still have the Dell 1028 and then the 1F51, which is the Dell mini monolithic subsystem product ID. And this here is the PCI class. 0107 is for the SAS controller, so this is basically an IT mode controller, whereas the PCI class for the RAID controller is 01004, which is for a RAID controller or SAS RAID controller. The other bits or the other bytes here, are not always clear to me what they really are. I can only kind of speculate. But yeah, so I'm thinking I'm going to try putting the IT mode EEPROM or the SBR contents from the IT mode EEPROM onto Peter's H310 Mini, and then we'll see if it actually boots up. If putting this SBR on it allows it to boot up, then we might be able to just go ahead and try to flash the IT mode firmware on it, and then we'll be good to go. So anyway, that's what I think I'm going to try to do. All right, so let's bring the EEPROM program here back again. So this time we're going to write the H310 Mini IT mode EEPROM contents into that chip. All right, let's see what happens here. Okay, so that's done. Just to be absolutely sure, I'm going to read that the contents of that EEPROM back out. I'll call it test.bin, and I just want to compare that the contents are correct. Okay, so if I do a diff on test.bin and the H310 Mini IT mode version of the EEPROM, okay, there's no difference. Okay, so I think that wrote correctly into the EEPROM chip. All right, so at this point I'm going to disconnect the clamp from the chip, and I'm going to put it back in the server and try to boot it up and see what we get. If it boots up, terrific. If it doesn't, then maybe I'm going to try writing the original H310 EEPROM and see if that allows it to boot up. All right guys, so I've installed the H310 back into the R720, and I've logged into the iDRAC interface here, and we're gonna try to boot this up and see what happens. All right, keep your fingers crossed. Okay, we see configuring memory. That's good. It's usually after the iDRAC message that you get the invalid PCI card. Come on. All right, so it's after this message that usually you get the invalid PCI card error. Well, what happened here? Why did I lose the signal? Oh, well. All right, so it looks like we got past that error. We're seeing the Dell logo. We're seeing the post messages showing up. And although I'm not seeing anything from the Dell PERC BIOS ROM, so I don't know if maybe Peter did manage to erase the flash perhaps, and there's just nothing on it. But I didn't see anything about that card. I mean, we're able to boot up, but I don't know if the card's actually recognized or not. All right, let's try to boot up here, and we'll do an LSPCI to see if we actually see the card. So if we don't see the card, we can't do anything about it. we need to be able to see the card in order to potentially reflash it with firmware. Alright, that looks a little better. I don't know why it's taking so long to boot. Makes me wonder if that card is causing a problem or not. I don't know. Yeah, okay, there were some messages there that kind of indicated of a problem there. So I'm not sure. We'll have to continue finish booting up here to see what we have and what we can work with. Alright, so we're fully booted up. Let's log in here. Alright, LSPCI. What do we have? Okay, so we have something. We have SAS SCSI controller. We've got LSI 1000. We've got 0072. Okay, so that's the right product ID. And then we've got the Dell 1028 and then the H310 monolithic 1F51. Okay, so far so good. We're seeing something. Whether this card is functional or not, I don't know. Let's take a look at. Let's see what driver. Okay, so it's recognizing, yeah, there's no driver loading. So this card probably doesn't have any firmware running, is my guess. The kernel is recognizing, probably based on the 1000 and 0072, that it's supposed to load the MPT2 SAS driver, but it's not actually loading. Alright, so do we have this tool? Okay. Let's see what we can do with this card. You know what? I'm going to log in over the network, just because it might be a little bit faster to read this text. So that was at 223. Let's log in. Okay. And you know what, I'm going to log in over here too. Because I want to see the kernel messages just to see if I can make something happen here. Alright, so we know the card exists and it's there. There's no firmware running on it. So I should be able to run, for example, unbind, which is there's no driver anyway. Okay, and I should be able to maybe run info. Okay, so IOC is in reset. So let's see if I can host boot this guy. Okay, I have the firmware here. Alright, let's try to host boot this guy. Host boot 2118. Let's see if this succeeds. Alright, says host boot successful. So that's good. So I think that means I can try to flash the firmware now. Alright, so let's do a rescan. All right, we're seeing the card show up, and it's detecting all my hard drives. Okay, but that's good. That's good. Okay, so we see. Let's double check this. Yep, the card is up. And do we have driver loading? Yes. Let's see here. Oops. Let's get rid of these options. Okay, so the driver is actually loading. All right, so host boot looks like it's fully successful. All right. At this point, let's see if LSIutil I know I have it here somewhere. Okay, LSIutil does see one port, so we'll connect to that port. And I think the first thing I want to do is all right, let's just make sure hold on here. All right, so let me break out of that actually. I think I'm going to do an erase first because I really don't know what's left on that flash. So let's erase the flash. Okay, and we'll also erase the manufacturing config pages. Okay, all right, so that's done. Next, I'm going to try to flash the firmware. So I don't know what option that was here. Let's see. Download firmware. So that's 2. All right, so it's 2118it.bin. Yes. All right, that seems to be successful. I'm going to also flash the BIOS. So that's option 4. Okay, so it's mpt2sas.rom, I believe. And no such file. All right, let's see here. What's the name of the file? It is mpt-sas2. Okay. All right, let's try this again. mpt-sas2.rom and no F code, and then that's x64sas.rom. Failure. Oh, come on. What was the file name on that? x64sas2. Okay, let's try this again. mpt-sas2.rom, x64sas2.rom. Yes. Okay, that looks like it succeeded. All right, so the only thing left is to program the SAS address, right? So let's see. Yeah, we got all that. Let me quit out of here. So if I were to run a list SAS to flash, yeah, the SAS address is missing. So Peter, I'm not sure what to do because you didn't provide me with a SAS address. So I might just make something up and hope that doesn't conflict, or it shouldn't at least. Alright, let me look at, I'm just going to take a SAS address from one of my other cards. I don't think you'll ever use one of the cards I have, so you might be able to just do that. Okay, now let's define where can we find change? Okay, 18. Oh. Is that not a valid option? I would think it would be. Alright, let's reset the card. Let's see what happens here. Let's reset the card. Come on. So by resetting the card, it should be automatically booting from flash. I don't need to host boot anymore, since I did put the firmware back on it. Let's see if it actually comes up though. Come on, come on. It's taking forever. Host reset failed. Well, that's not good. Alright, let's see. Do we still have this card? Alright, so we still see the card. See. Looks like there's a driver loaded on it. Alright. Let's just reset it. Unbind. Let's take it offline. Okay, and it's in reset stage now. So let's reset it. And scan. Okay, looks like it booted up now. Okay, good. IOC is operational. Awesome. Okay, so I think that actually booted up from its flash. I didn't do any let's see. Alright, okay, so yep. That booted up from flash, so that's a good sign that it's able to boot up by itself. Still missing the SAS address, so let's take care of that one right now. SAS add. Okay, it's going to reset again, so it'll load the new SAS address. Okay, there we go. So I think we have a working card. We've actually recovered this card. So congratulations, Peter. I'll be sending this back to you. And thank you very much for sharing this bricked card with me so that I could actually try this. Alright, so that looks good to me. One last test. I'm going to actually reboot the server. And this time, since I did load the BIOS ROM, we should see that during post. And this is great news. Alright, so we have a way to recover these bricked cards, potentially. Alright, let's see what happens on reboot. Alright, configure memory, initializing IDRAC. We got past this part last time, and it went do the Dell logo. Alright, so we see the Dell logo, good. And we should start seeing the post messages. So hopefully here we see the, yeah, there we go. The Avago BIOS ROM here is loading. Okie doke, yep. SAS 2008 IT mode. It sees all the hard drives and SSDs I have in this machine. Awesome. So I think this is working. We've got a recovered H310 Mini now with IT mode firmware on it. Alright, let's boot up. Something failed there. Just scrolled by really quick and I didn't see what that was, but I guess we'll log in later and check it out. Okay, let's log in here. Alright, so do I see all the hard drives? I do. Awesome, awesome. Okay, DMM, and then grep LSI. We see the card is there. The driver is loaded. Yeah, that's awesome. So looks like it's there. Let's look at the kernel messages. Yep, port enabled success. So I believe I have a Z pool or ZFS pool here. So let's see if I can import it on those 12 drives. Z pool status. Awesome. Okay, yeah, the Z pool on those 12 drives on this R720 XT loaded up perfectly fine. And so yeah, this is it. So hey, congratulations, Peter. Looks like you're getting your H310 back with in a recovered state with IT mode firmware on it. All right, so hey, I didn't really know what was going to happen here today. Obviously, there was a couple of missteps there. So if you guys are trying to recover a H310 Mini, hopefully this video was helpful to you. It wasn't, you know, the sanitized version. I just kind of want to share the experience with you guys, but apparently it is possible. And hopefully if you go through this video you can pick out the steps that are required. Obviously there were a few steps there that didn't work out, but anyway, it looks like it is possible to recover the H310 Mini. Looks like I think the key component was to put the SBR on that EEPROM chip so that the card would actually pass that post test at the beginning when you boot up the machine. And once you get past that point, you have access to the card to flash the firmware on it or do whatever else you want to do on that card. So that's really the key component. Get the SBR correct on that EEPROM chip so that you can actually boot the machine with that card installed. And then after that, it's just a matter of fiddling around with the flashing tools to get the firmware back on that card. And if you don't have a firmware on the card, then you have to host boot like I did. And the host boot just means to boot the firmware off a file that you have like on the host. And so once that's loaded up, the other utilities to flash the firmware will work, and then you can actually write to the flash and so or manipulate, you know, the contents of the flash. So we did initially an erase because I just really wasn't sure what was left on that flash chip. You know, I wasn't fully aware of the state that the card was in when Peter sent it to me, so I just wanted to make sure that it was completely erased. And then we managed to flash the firmware on it, the BIOS ROM, and that kind of stuff, and then added the SAS address. So, all right, well, that's it, guys. Hope you enjoyed this video, and if you liked it, please hit the like button, and if you'd like to see more videos from me, make sure to subscribe, and I'll see you in the next one. All right, bye-bye.